Good morning, class. Today we will discuss the concept of function. Before that, we have already learned about the relation. So, if we have two sets, set A and B, these are the two sets that we are having, and we are defining a relation from the set A to set B by. Now, how we are defining the relation? That R is a relation which is having all the ordered pairs x, y such that where x is coming from the set A, y is coming from the set B, and what is the relationship between these two elements? That y is equal to x square. That means the second element is the square of the first element. If I am defining this kind of relation and I take A is the set, let us do it by arrow diagram so that you people can understand, because from the concept of relation we will move to the concept of function. Now if I have here the element 0, 1, 2 and 3. These are the four elements that I am having in set A. Here we have 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now, and if I say let us take instead of 3, this 3 element I am eliminating. Why I am eliminating it? I want you people to understand one thing here so that we can shift from the concept of relation to the concept of function. Okay. Now under this relation we are taking every x is coming from set A and the second element is actually the square. Now based upon this relation 0 will go to 0 because square of 0 is 0. Square of 1 is 1 only. Square of 2 is 4. And 3 I have eliminated. Why I did that? Because I don't have here 9, so I won't be able to connect this 3 anywhere in the set B. So this is the reason I have removed this 3. Okay. Now if you notice here in this relation R, every element of set A is connected to one and a unique element in set B. It's not like that 0 is going to 0 also, or 1 also, or 2 also. 1 is going to only one element 1, 2 is going to only one element 4. So there is no such kind of criteria or no such kind of condition we are getting here where one element is having two images and so on. Now when a relation now comes to the definition of function. What is a function? When relation R, when in relation R every element of set A has one and only one image in set B, then R is called function. And now this relation will have another name, function. Okay. Now so it means the relation only becomes function under specific condition. What is the specific condition? When every element of the set A, right, if R is defined from A to B and every element of set A is having a unique image means one and only one image in set B, then this relation will be called function. So now this relation has become a function. Okay. And if I make here 3, by chance if 3 element was present here, then what will happen? This 3 element will not have any image in the set B, and then this relation will remain as the relation only. It will not become the function. Are you getting my point? The relation will become a function if every element of set A has a unique image in set B. Only then the relation will be called function, right? And now if you remember, in the relation, the collection of the first elements of the ordered pairs. So if I write down this relation in the roster form, I will have 0, 0, 1, 1 and 2, 4. 0, 1, 2, that means the first element of every ordered pair. 0, 1, 2. Here also 0, 1, 2. Only these three elements are present in the set A. And what is the definition of domain? Collection of all the first elements of the relation is called domain. Now what is happening here? Every element of set A is having an image. That means in the function now, what will be the condition? The whole set A will be called domain of the function. The whole set A will be called domain of the function, and the whole set B will have the same name as it was having in the relation concept. It is called codomain. And the collection of images, how many images we have? 3 images, and these are 0, 1 and 4, and the collection of images will be called range. So what is the domain here? Domain is the whole set A. What is codomain? Codomain will be the whole set B. And what is the range? Range is the collection of images 0, 1 and 4. I hope the concept is clear. There is a small change in the relation and function. The relation only becomes function under a certain condition. And what is the condition? When every element of the first set has a unique image in the second set. If by chance there is only one element left which is not having image and all other elements are having the image, then also it will not be considered as the function. Even if one element is having 2 images or 3 images, then also I can't say it is a function. Let us take one example. Let us take the example here. If I have here set P, it is having the elements -1, -2, 0, 1 and 2. And there is another set Q which is having the elements 0, 1, 2, 3 and 4. Now, and the same relation if I define here, R is the relation which is having all the ordered pairs x, y such that y is equal to x square. Okay, now we know the square of -1 will be 1. Okay, square of -2 will be 4. Square of 0 will be 0. Square of 1 will be 1. Square of 2 will be 4. Okay, here what is happening? I am repeating my statement. If every element of first set is having a unique image in the second set, then it is a function. Okay, I think here the condition is getting satisfied. The image of -1 is 1. The image of -2 is 4. The image of 0 is 0 only. The image of 1 is 1 only. The image of 2 is 4 only. And if I write down it in the roster form, it will be 0, 0, -1, 1, then -2, 4, then 2, 4 and 1, 1. Now what is happening here? It is not like that the first element is having 2 images. There is no repetition of the first element in the roster form. There is only 1 times 0, there is only 1 time -1, only once -2 has come, only once 2 has come, only once 1 has come. So again, I will say this is a function. Okay, I hope you are getting my point, because the statement says the elements of set P should have unique images in set Q. But it doesn't mean that 2 elements cannot have the same image. 2 elements can have the same image, as we are getting here. The image of -1 and the image of 1 is 1 only. And the image of -2 and 2, that is also 1 only, that is 4. So this condition is possible. We can have this way. I will say it is a function. Now, when I will say it is not a function, for example, any relation, let it be R1, any relation R2 is given in such a way, we are having A, apple, right? We are having B, bat. We are having here A, let us say air. That's it. Now what is the difference here? A is having the image apple also, A is having the image air also. So now one element is having two images. That means the image of A is not unique. So here A and this A, this is the repetition. The repetition of first element, right? It is repeated. So that means this is not a function, right? If the first element is repeated in within the given relation, that relation will not be considered as the function. But yes, the second element can get repeated. If the second element is repeated but there is no repetition of the first element, then it is a function. So this is the difference when the repetition of first element and the repetition of second element. Repetition of second element is okay, it is a function. Repetition of first element of ordered pair, if it is there, then it is not a function. So R1 is a function, R2 is not a function. Okay, and now what will be the domain of this set? This relation means this function. The domain of this function will be the whole set P. The whole set Q will be the codomain, and the elements 0, 1, 4, that will be the range. And these elements 0, 1 and 4, in the relation these are called images, in the function these are again called images. So these 0, 1, 4, that means all the second elements of ordered pairs, these are called images. And this is the image of what? 0 is the image of 0, 1 is the image of -1, 4 is the image of -2. Now here the first term of every ordered pair is also having a name. In the relation, no name is given to the first element, but in the function, the first element is also given the name. And what is the name of the first element? Now, if I take this first element, that means all the first elements of the ordered pairs, then the name is pre-image, right? So in every ordered pair, the first element is called pre-image and the second element is called image. It means when I am looking at the domain, every element of the domain is called pre-image of that element to which it is connected, right? So -1 is the pre-image of 1, or what I will say, 1 is the image of -1. 0 is the image of 0 and this 0 is the pre-image of this 0. 2 is the pre-image of 4, 4 is the image of 2 and 4 is the image of -2 also, right? I hope the terminology is clear in the concept of function, because if I understand all these things and the base of the function, then it is clear. We are first moving from the definition of relation to the definition of function. So this is all about the definition of function. Okay, now how the function works, that we will understand. How the function work, let me write down working of function. Okay, now let me remind you people, we know if there are addition, subtraction, multiplication and division, these are called mathematical operators. And in order to use any one of these operators, how many numbers we need? At least 2 numbers should be there, right? So these are called mathematical operators. Likewise, how the function work, because plus will not work alone, I need a and b 2 numbers, and when I do a plus b, I am getting a certain answer, right? Minus can't work alone, it should have 2 numbers. Likewise, working of function cannot work on its own. If this is the function f, then it is acting as a machine. It is acting as a machine. So what does machine need? Machine needs an input. Okay, so I should have some input to be given to the function, which is a machine. And now this function f, since it is a machine, it will work on the input and it will give us the output. So output we will get once the input is given to the function, right? So this is the function. Till now in junior classes we have used this thing many times. For example, if it is given f of x is equals to 2x minus 1, and we know that find f of 1 or find f of 2 and so on. And what we used to do, in place of x, what we do, we put 1. So here in place of x 1 will come, so it will be 2 into 1 minus 1, so the answer is coming 1. If I put 2, it will become, answer will be 3 and so on. And we say this is function f of x. Fx is a function is equals to 2x minus 1. Okay, so if I consider this example, let us see how this f is working on this x. Okay, so we will discuss the example here. It is, I am taking the same function f of x is equals to 2x minus 1. So what is happening here, this f is a function. This x which we are writing here in the bracket is a input. So when this f is taking x, it is giving this thing, and this is the output, right? Okay, f is a function, f of x complete, we call it f of x, but f alone is a function, x is the input, 2x minus 1 is the output in our example. That means when this machine f is given here, what it is doing, if I am giving x to this function input, what this function is doing according to this, first of all it is multiplying x with 2, right? First of all, what this function is doing, it is doing multiplying x with 2, it is getting 2x, right? And once x is multiplied by 2, then from the answer it is subtracting 1, and this is the output, right? This is the output, right? See, you people might find it a very simple thing, but when it comes to the role of a function, many people get confused, because when I am using something, I should know the whole concept of that part. So my motive here to explain is fx is equals to 2x minus 1, or fx is equals to anything. When we write this, x is actually the input. Now what function is doing, it is taking x, it is multiplying x with 2 and subtracting 1, that is the result. So here if I take any example based upon this function, now if I give 1 to the function, what is it happening, or what is happening here, it is in wherever x is there, it is putting 1 and then doing the answer, so the answer is 1. If I give here 1 by 2, then it will become 2, 1 by 2 minus 1, so the answer will be 0, and so on. Okay, so this is how the function works. Function is nothing but it's a machine, you can take it as, and x, whatever you are writing here, f of, in the bracket, this term is actually the input, and the RHS equal to whatever RHS is given, that is the output. That means function has worked on x, and this is the result, right? So I hope the working of function is clear, and now we have different types of functions that we will discuss here, and here we are giving the heading types of functions. Okay, under types of functions, the very first thing that we will do, it is real valued function. Real valued function, what does it mean? It means the function which is taking the real number and giving the real number. So what I will say here, we will write down a function f having a set of real numbers, are, or subset of it as domain and codomain, domain as well as codomain. In other words, if f is a function defined from R to R, right, then this is a real valued function. So real valued function means it is taking the real number, and I know I hope everybody knows the set of real numbers is the largest set in our set system, right, in our number system. So when a function takes the real number and give back the real number, that function will be called real valued function. If I look at this function, this x, in the example I have taken 1, and we know 1 is a real number, 1 by 2, 1 by 2 is also a real number. If I find f of 0, that will also a real number, 0 is a real number, minus 1 is also a real number, and so on. So in other words, every function that we work on, right, is actually a real valued function only, right? So this is nothing new. Whatever functions we have used and we are using and we will be using, most of the functions are real valued functions, unless and until it is specified that we are considering the imaginary terms also, and so on, right? So this is all about the real valued function. This is the simple definition, and further after this, whatever functions we are going to discuss, all the functions are real valued functions only. Okay, this is the first definition, real valued function. And now we will move to the very first type of the function, that is called the first function we will consider, or let it be the second function, because we have given the number here first. So let it be constant function. Constant, we know constant means which does not change. Okay, so now how the constant function will work? It means when I define, or let I say, let f be a function defined from R to R only by, how the function is defined, f of x is equals to c, where x belongs to set of real numbers, and what is c? C is constant. Either you write down c is constant, or it is a fixed real number. So what is the constant function? The function, whatever x I give to the function, the result is only constant. What does it mean? See, in class 10 you people have done the chapter graphical solution of linear equations, right? And there what we used to do, whatever equation is there, we write down f of x, and instead of f of x, I think you people might have done y is equals to some equation line is there, let us say 2x plus 3 line is there, and by putting different values of x we are getting the values of y, and so on. The same thing we are doing here. Now instead of y, what we are having here, we are having f of x. Otherwise the plotting will remain the same. How will we do? Because here for each and every function we will do the plotting, so that we can understand the nature of the function, how it is working or how it is operating when we are plotting the function, or when we talk about the function. Okay, so let us discuss the example, or to understand the concept. Here I will fix the value of c so that we can do it. For example, I am taking here, let c is equals to 3. Okay, we are fixing the value of c. You can take any value, and what is happening here, it means f of x is equal to 3 I am writing. Now this x is coming from the set of real numbers. That means this x can be positive number, can be negative number, can be a fraction, can be a rational number, irrational number, anything it can be. And how it is happening here, if I want to plot it, I need the points. Just like your class 10 concept, in place of y, here what do we have? We have f of x. So in place of y, you people will write down f of x, otherwise the same thing. Now let us take different values so that we can plot the function. First, when x is 0, what is happening? Whatever x is there, x belongs to all real numbers. Whatever x is there, it is not doing nothing to the x. It is giving you the constant value, right? It is not doing anything to the input. So when x is 0, then also output is 3. When x is minus 1, then also output is 3. When x is 1, output is 3. When x is 2, then also output is 3. When x is minus 2, then also output is 3. When I am taking x as 1 by 2, then also output is 3, and so on. What is happening here? X is changing, input is changing, but output is not changing. When input is changing but output is not changing, it means it is a constant function. And here we are supposed to plot the graph also for each and every function that we are going to discuss. So let us do that. We are taking here, this will be x-axis, this will be negative x-axis, this is our y-axis, and this will be negative y-axis, right? So let us mark the points. Let it be 1, 2, 3, 4, 5, and so on. Let it be minus 1, minus 2, minus 3, and so on. Here 1, 2, 3, and so on. Minus 1, minus 2, minus 3. Okay. Okay, when x is 0, the value of fx. So in place of, that means where we will take the values of fx along y-axis. So the vertical real number line, that will act as f of x, and the horizontal near real number line will act as values of x or x-axis. So when x is 0, so this is our origin 0, 0. When x is 0, y is taking 3. Y means f of x. When x is minus 1, then also it is taking 3. When x is plus 1, then also it is taking 3. When x is 2, then also 3. Even when x is 3, then also it will take 3. Minus 2, then also 3. Minus 3, then also 3. So whatever be the input, the line is coming like this. It is a straight line parallel to which axis? Parallel to x-axis. And what is the distance between these two lines? That is actually 3, right? So this 3 is what? Where we are fixing the value of c. Okay, so it is your choice. You can fix the value of c as 4, 5, 1 or 2 or 1.5, anything. Okay, but we are taking different values of x. That means the input is changing but output is constant. So that is why it is called constant function. So this is the graph of constant function. So if somebody asks you what is the graph of constant function, it is a straight line parallel to x-axis at a distance c. At a distance c from x-axis. And now this c can be anything. It can be positive number, it can be negative number also. This c can be minus 3 as well. So it will go below x-axis. And if it is positive, it will be above x-axis. Right? I hope the function is clear. This is our constant function. And the next function that we will discuss, it is identity function. Identity function. Now identity function means, let me show you. If I have, let f be a function defined from the set of real numbers to the set of real numbers only. Now see, f is defined from R to R. That means the domain and codomain both are set of real numbers only. So it is a real valued function again. F be a function defined by, how the function is defined, that f of x is equal to x for all x belonging to the set of real numbers, because this x is coming from the domain. And what is the domain? Domain is the set of real numbers only. So what is happening? Identity function, whatever I am giving to the function, the output is same. So input and output both are same. So identity function, in other words, if I have to remember the concept of identity function, that means it does not change the identity of the input. Whatever input is there, same is the output. So when input and output are same under the function, that function will be called identity function. So when I take the values, if I take the values x and f of x, it means when x is 0, the input if 0, output is also 0. If I give 1 to the function, the output is also 1. If I give 2 to the function, output is 2. If I give minus 2 to the function, output is minus 2, and so on. In other words, whatever I am giving to the function as the input, it is giving me the same number back as the output. So when we plot this function here, so what will happen? Let us plot it. X-axis, x dash, y, y dash. So if I mark it as 1, 2, 3 and 4, and this is -1, -2 and -3. This is 1, 2 and 3, and here let it be -1. Okay, so what is happening, and this is our origin 0, 0. What is happening when the input is 0, output is also 0. When the input is 1, output is 1. When the input is 2, output is also 2. When the input is 3, output is also 3. When the input is -1, output is also -1. And if I mark it as -2, if the input is -2, output is also -2, and so on. And now if I join these points, right, what is happening here? We are getting again a straight line passing through the origin. Here what we were getting? We were getting a straight line parallel to x-axis. But in the identity function, we are getting a straight line passing through the origin. So constant function, straight line parallel to x-axis. Identity function, straight line passing through the origin. So these are the two functions that we have done right now: constant function and identity function, right? So identity function, which does not change the identity of the input. Constant function, whatever input you give to the function, output is fixed. Output is not changing, it is constant. So that is why the function is called constant function, right? You people should plot the graph using the graph sheet, and you can paste the graph sheet with plotted graph in your maths notebook, and do it neatly also. And now we will move to the next function. So the next function that we will discuss is polynomial function, right? Polynomial, you people know very well what is the polynomial, but now we will talk about polynomial function. What will be the polynomial function? Again, a function f, from R to R, that means domain and codomain both are real numbers, is called polynomial function, for each x belonging to R, when y you can write down, or f of x you can write down. F of x will be equals to a naught plus a1x plus a2x square plus a3x cube up to so on. The last term will be a n x power n. Now a naught, a1, a2, a3 up to so on an. The coefficients, these coefficients again will be real numbers only, right? And if I have here the coefficient, for example, a1, a2, a0, a1, a2 coefficients are there, but a3, a4 and so on, these coefficients are 0, right? Then what I will get? I will get the quadratic function. If I have a1, a0 is there, a1 is there, a2, a3, all these coefficients are non-zero, but after this all other coefficients are 0, then what will happen? It will become a cubic function. And if all these coefficients are 0 after a1, then I will have these two terms only, a0 and a1x, so this will become a linear function. And if even a1 is also 0, I am having f of x is equals to a0, so it is becoming a constant function. Alright, so what is happening? It depends upon the different values of these coefficients. So if I make the coefficient 0, I am getting different kind of functions further, right? Under this polynomial function, the very first function that we will discuss is a square function, right? Now square function means whatever I am giving to the function, it is giving me the square of that number. Simple words. So a function f from R to R is said to be square function if f of x is equal to x square for all x belonging to the set of real numbers. That means whatever x I am giving to the function, it is always giving me square of that number. So that function will be called square function, right? So if I make the table to plot the graph of this function, if I give -1 to the function, square of -1 is 1. If I give -2 to the function, square is 4. If I give 0, square of 0 is 0. If I give +2, it is 4. If I give 3, the square of 3 is 9. If I give -3, then also square is 9. Even you can do, if I give 1/2, the square is 1/4. If I give -1/2, the square again will be 1/4, and so on, right? So here the input can be negative or positive, but the output is always positive, right? This is the difference, because square of every real number is a positive number, right? So input can be negative, can be positive. That means input is all real numbers, and here I can say when the output I am talking about, that means when the image is there, every image is a positive real number. So here what we can say, the domain is real numbers, codomain is real numbers, but the range is positive real numbers, right? So let us plot this function to get the shape of the graph, how we are getting it. Okay, so you people are supposed to use the scale. I'm not using the scale, but it should be there, right? So this is our x dash, this is our x. Let us mark the point. Let it be 1, 2, 3 and 4, and here also -1, -2, -3, -4, and here let us mark 1, 2, 3, 4, 5, 6, 7 and so on, right? Now the image of 0 is 0, so it will come here. The image of 1 is 1. The image of -1 is also is 1. The image of 2 is 4, so it will come here. The image of -2 is also 4, so it will come here. And for the image of -3, I have not plotted till number 9. If you people can do that, right? And so on. So when I join these points freehand, right, no need to use the scale, this point will get joined, this point will get joined, and so on. It will go like this. Similarly, this side point join, we will join the points freehand, and it will go like this. Now when I look at the diagram, what kind of shape it is, it will be U-shaped graph or upward parabola. So what is the graph of the square function? The graph of the square function is a U-shaped graph, right? You people have to plot it. Once again I am repeating, you people have to plot it on the graph sheet only, and the figure will be very clear, neat. It should be neat also, and every function you have to plot. Clear? So this is the square function. So here we can write down also what is the domain of this function? All real numbers. What is the codomain of this function? That is also all real numbers. And what is the range of this function? That is positive real numbers, right? R plus. And let us write down the domain and codomain for the other functions also that we have discussed. Okay, and in the beginning we have discussed, first function that we discussed was the constant function. What is the domain of the constant function? Domain is all real numbers. Codomain is also all real numbers. But what is the range? Since we are fixing, there is only one output always, so there is only one element as the image, so the range will be a singleton set containing that constant. Now this C can be anything. Identity function also. What is the domain of the identity function? All real numbers. What is the codomain of the identity function? All real numbers. And what is the range of the identity function, that is also all real numbers. So in identity function, domain, codomain, range, all three are same, that is the set of real numbers, right? I hope these three functions, constant function, identity function, and the last square function, are clear. So you people have to do this part. The remaining we will discuss in the next class. Thank you, students.